This is a classic elastic collision problem. Watch this. This is in grams. You have to convert to kilograms. You're going to have conservation of momentum. So you say m1 v1 plus m2 v2. This is before the collision is equal to m1. Actually, yeah, v1 plus m2 v2. Your two variables are v1 and v2. By the way, I set these. I call v1x and v2y. And then I plug in all my numbers and I get an equation. Then because in an elastic collision, both the momentum and kinetic energy are conserved, I basically do the exact same thing, 1/2 mv squared. Again, plug in all the numbers that I know. And this, by the way, because the second one's at rest, these two terms here and here will be 0, will be equal 1/2 m, and watch how I do. Instead I say x squared plus 1/2 my squared. Now I have two equations. I then go to Desmos. Right, the first equation, for example, what do I have here? I did the math. I got this to be 0.101 is equal to 0.046x plus 0.026y. I actually typed it just like that into Desmos, and then did the same ball game with this one. And then when you look at the Desmos, you're going to have a line and a circle, right? This is a circle, equation 2. Equation 1 is the line. What you'll have is 2 points, like say this point and this point. Now these I just drew them at the origin. They're not going to be at the origin. Maybe one of them is. You're going to have two sets of numbers, and only one set of numbers is going to make sense. So one of these intersection points is the correct answer. So once you've graphed it, you can easily figure out what the correct answers are to, if you will, A and B.